We've designed an ADC peripheral for SCOMP that will allow SCOMP to communicate with the ADC chip found on the DE10 board. Our main goal was to help minimize the data collection delay for the user and to help overall simplify the SCOMP user interface. The overall design of the ADC peripheral is based on a state machine and 8 available registers that correspond to the ADC's 8 available inputs. The peripheral is going to intake the ADC's 12-bit information and convert that to SCOMP's 16-bit information from all 8 channels asynchronously in 4 stages. The peripheral will continuously initialize ADC in a unipolar single-ended mode, which the user cannot change. It's request data from a selected channel starting from channel 1, and it's going to use the SBI format to push the next command onto the ADC while also receiving the information from the ADC from the current channel. That data is then stored into the selected channel and repeated continuously for all 8 channels, allowing that information on the registers to be available to SCOMP at any available time, which will greatly minimize the delay. As data from the ADC is collected asynchronously for the user from all 8 channels, all of that data is available at any request from SCOMP. So SCOMP's user interface only has in with the corresponding address from hex numbers C0 to C7. So the user only has to call in with the address to pull the most recent information from the ADC peripheral. To demonstrate the capabilities of our ADC peripheral, we designed a game called Match the Signal, in which the user has access to 2 potentiometers, which are feeding 0 to 4 volts into the ADC chip itself. SCOMP is using the peripheral to pull information from the ADC on channels 0 and 2, filtering that information through a step function corresponding 0 to 4 volts to the LEDs 0 through 9 in 0.4 volt increments. We can see that each knob is able to work independently, showcasing that the ADC is able to pull information from both channels synchronously without waiting additional clock cycles or needing the user to program in additional clock cycles for SCOMP to successfully pull in all the information. The user's goal for the game is to ultimately match the lights at the same signal, which can occur at any location. So it does not matter if they match in the middle, if they match at the ends, on either side. So going through a couple of rounds of correctly going through the game, again, the goal is to match the signals within 0.4 volts of each other, which can happen at any location. So this one, we match them at the very bottom, and they match. So it goes back into the win state, go into reset. Again, the signals are able to take information from each channel synchronously, so we have available information of the most recent data from the ADC that the user can pull from, and we can extrapolate this that you can pull from any channel if you programmed it in the assembly code. Now there is a flaw to this, as we are limited by SCOMP's clock speed, so here we're set a little bit slow, so moving the potentiometer very quickly allows the ADC to pick up the next available signal, which might be higher than the win condition even if you passed over it. As you can see, it skips right over it. It doesn't trigger the win condition. If moved slowly, then it does. Going into one last game, we can see from the reset state, we're going to try to match from the high side. So the ADC is again giving reliable, correct information from whatever voltage the potentiometers are putting out. And you do have to be within the 0.4 volt range for it to accurately do the win condition. In conclusion, our ADC peripheral's design of asynchronously pulling data from all the ADC channels. In this case, we were using channels 0 and 2, but the user could effectively use all the channels if they wanted, or select from any channel combination that they wish. Each of these channels is immediately available on those registers, and the user does not have to wait additional delay cycles for correct information or program that into SCOMP to wait for those information. So that limits the user's complexity by simplifying to only the in command with the address, and ultimately the user could extend the uses of this peripheral to other analog sources.